Good morning. This is going to be the video on how to do the clock front cam work, but it's also going to cover, before we get started, one quick thing on modeling the clock in order to better produce the cam. So the first thing here is the three holes that go around the center to bolt the clock together. What we want here is we want actually a countersunk threaded hole. So if you go into here and go edit feature, you want to choose countersink. 0.22 would be the countersink diameter. 82 degrees is fine, and then it needs to be a 1224 threaded hole to a depth of 0.35 deep. And then we want to offset from the bottom um, to make this 0.3 so that the thread doesn't go all the way down. We want to do that because we need this countersink for an operation on the cam side. So we click OK, and then I just circular pattern that the 3 times. So now that we have the model the way we need to switch over to manufacturing. So you're going to have to upload the tool library. Once again, right click, import tool library, go to your downloads, which you'll download this from Schoology. And there's the clock tool library. You'd obviously hit open. I already did it, so I didn't do that. So now that we have the tool library, we have to do a setup. So we click setup. Now the clock here is a cylinder to start with. It's a plastic disc. So we need to actually start on the stock side and switch this from a fixed size box to a fixed size cylinder. And that fixed size cylinder has a diameter of 4.75 and a height of 0.5. Now, obviously, there's our cylinder, but it's not oriented correctly. And then if we click on axis, all we have to do is find one of the circles, either the center bore or the outer bore, and that will now line it up. Now we have the stock right. Now we can go back to setup. So the origin, the Z, it needs to be located here. It'll probably move on me, but it needs to be located here. The Z needs to be going up. So we're going to choose ZX, select the Z line right there. So now the Z is going up. That's the direction we want it. The other thing we need is we are going to clamp. The clamp's going to be here and here, holding this disc in place. So we're actually going to machine it on its side. We need this little flat to be off to the right. So we need the red arrow to be pointing at the flat. So we're going to use the x-axis and select the x-axis. So now we got it in the right orientation, and then I can move it to the point I want. There we go. So we have it on the surface of the part. We have it pointing towards the flat. Okay, also within the setup tab, we need to go to post processor. And here under WCS offsets, we are going to put in a 3. Now what this should do is this should give our work offset. It should change it from G54, that's 0, G55 is 1, G56 is 2, to G57 as 3. So this is how we can preset the work offset. So we go ahead and click OK. First thing we're going to do is we need to drill this hole. If we drill the hole after we machine out the flat, this pocket, it's too thin and it tends to just break out. So what we need to do is drill it first and then machine the pocket. So we're going to go to drill, and from our tool library, we are going to choose the 5/16 drill bit tool, tool number 2. We are going to then select the bore, and then here we need to make some changes under height. So first off, not top of the hole, we need top of the stock. And second off, we need to push the tip through, because if we look right here, you'll notice the tips, it's not actually drilling all the way through. So if we push the tip through, it is now. And then we are going to add 0.025 just to make sure we get all the way through for any variation there might be in the thickness of the material. So we go ahead and click OK. And there we go. We now have our hole drilled all the way through. Next is we're going to do adaptive clearing to get rid of this material. So let's go to the adaptive clearing. We're going to select there. We are going to select the 3/8 end mill, which should be tool number. We're going to have to change these tools. The 3/8 end mill should be tool number 3, I believe. So we're going to click OK. So let's go ahead and make that edit. Let's go into the tool library and go to clock and go to the 3/8 end mill and go edit. And this is tool number 3. Okay, so we're going to go 2D adaptive. We're going to go to the tool library. We need to select out of the clock one, and there's our tool number 3. Click OK. We're going to do this surface. None of this changes. The only thing that changes over here is optimal load. We're going to lower that to 0.1. And we're going to click OK. And you can see it spirals in and clears out most of the material. Next, we're going to do a 2D pocket here. And then same tool, so we already have that. We need to go to passes and turn off stock to leave because we want to cut it to the actual size. And there we go. Now, with the same tool, we want to cut along just that line. So we're going to do a 2D contour. And when we same tool, so we're going to select this geometry and then we're going to double click on it and we're going to switch to the open geometry and then click add. So now we have just that line. And if we click OK, you'll notice that it just puts this line. We can't cut all the way around the outside because the jaw of the vise that holds this in place, you'd cut right through it. I did forget one step on that. So we go into edit. We actually want to push this down like -0.05. So we're cutting with the side of the cutter, not the very edge. The very corner is the weakest part, so we're going to be using this area up here. So we now have that done. And now it's time to put in the holes. So these are just going to be 3 drilling commands. So my first drilling command, I'm going to select the cone. I am going to click on same diameters, so it gets me all 3. And then I am going to change the tool to our 3/8 spot drill. And then I am going to click OK. Then I'm going to do another drilling command. This time my tool is going to be the number 16 drill bit, tool number 9. I am then going to do same diameter and select that surface there. Oops. There we go. So it picked up all the diameters. Nothing changes here, and we click OK. Now, the last one is going to be a tapping. So we use drill again. This time we have to select the tapping tool, which is tool number 7. And then we need to come across to geometry, same diameters, select the places. Now, there is one step here. Bottom of the hole, we want to offset it 0.05. And what that's going to do is if we look, you can see how far down it's going. And then if we switch to here, we'll notice that it's slightly different. That there's a deeper, that it's a little bit deeper. So we want it to stop a little bit short. So now that we have it all done, we can go ahead and simulate. Turn on stock, hit play, speed it up a little bit. And there we go. It went fast through that cut, but we got everything we needed. So now this is done. It's time to post-process. So we hit post-process. We're going to be running this on the Haas pre-gen controller. Now we're going to run it on the older machine, so we have to lower this to 200. Once again, you're going to use your student body number. Mine happens to be that. And I'm going to use your name, clock, front, can't use periods, and your name. Okay, and once you get that done, we're going to hit post. I'm going to save it to the downloads and hit save. And now we have our clock front code up. And if we look here, oops, I got the numbers off. It works out as G56. That'll be fine. but it automatically puts in G56. So 1 must have been G54, G55 is 2, and G56 is 3. So there are the posts. Now we have it posting out the way we want. And you could take this out and simulate it on the simulators, and then we should be ready to cut it on the TM3.